I'm going to be showing you a very early prototype of a project we're building in NumFocus's Open Source Science Initiative. The project's called the Map of Open Source Science, or MOSS. So why are we building this? What's the problem? Let me show you the problem. This is the problem. This is what you see when you enter the open source research software space. There's a giant blob of information, no direction. Researchers don't know what tools exist to support specific domains or what tools they could use across domains or who to get in contact with to get support developing a tool for a niche use case. Developers and contributors don't know what tools or functions need to be built. Funders don't know what projects to fund or the impact of their funding. No one knows what gaps exist with regards to domain-specific tooling. No one can easily identify the papers produced by this open source research software, the patents that come from those papers, or the products that come from those patents. No one can see the downstream impact of a security flaw found in a project or a tool. No one can see what universities, institutions, industry players, or any entity incubate, support, or advance what projects. And most important to me, and on a personal level, no one can see the impact and importance of the people who are building these tools and who are involved with these entities and organizations. No one can see the importance of them on the whole open source research software system. Basically, we're all presented with this amorphous blob of information and told to make sense of it. That is the problem. So our goal with MOSS is to produce a tool that can be used by anyone to visualize this information in whatever way best fits their needs. So a funder, for example, might visualize it in a way to help them look for impact of their funding or to look for projects that are filling gaps in the tooling ecosystem that might make a big impact down the road. A researcher entering a new field, on the other hand, might look for tools that are used by their peers or tools they might come across in this work, tools and projects that will help them as they develop their career in this new field of research. Or an institution or industry-based entity might be looking for security or stability, and they find a new security flaw in a project they use, and they need to figure out who to contact and how, and what other tools might be affected downstream by this new threat, and what possible alternative projects might be expanded to fill this gap in the ecosystem that's left by this now flawed project. So what we're building is an interactive, composable map of open source science that people can use to guide them through this vast amorphous blob of information, this giant ecosystem that is open source science. And they can be leveraged to tell the stories of these projects, the stories of the organizations that support these projects, the institutions and that incubate some of these projects, the people that start these projects to fill a piece of research and then are forgotten over time as their project becomes abandonware. We want to tell the stories of these people, these organizations, these projects that define our society by helping produce the knowledge that informs our technological, political, economical, and humanitarian systems. So I'm going to take you through two stories in this demo, but I need to give you a few disclaimers very quickly. First, nothing on this map is guaranteed to be accurate at this point. This is a very early prototype. A lot of stuff is very accurate, but many other things are decisions we had to make simply to populate the map. You know, we're defining what projects are used in what domain, and that is an entirely incomplete mapping. We have essentially made sure each project is connected to at least one domain of science, right? And that we know that most projects are connected to multiple domains of science. In that regard, this is disclaimer number two. This is an experiment, so nothing here is sacrosanct. Everything here can be changed. It's a discussion, and it's a disclaimer number three. It opens a door to a much deeper discussion. Everything here, for example, these blobs you're looking at. Green blobs are people. Red blobs are projects, and the people are sized by the number of commits they have made to various projects. And that, of course, is a very inaccurate way to determine the value of a contributor to these projects. But it is the easiest way to measure just with the click of a button, right? You just get some information off of GitHub and you bring it into the map. So our goal here is to demonstrate the value of this type of map, not to say the metrics and the values we're using are the things that should be used. The projects, as the other example, are sized based on the number of dependencies that are connected to them. It's a good way to measure it if you're looking at the map to measure the value of a project if you're looking at the map from a specific perspective. But let's say I'm a new researcher looking for tools used by my peers. I'm not going to care how many dependencies, how many projects depend on whatever I'm looking at. So the point here is all these metrics that we use in this map are the simplest metric we could use to just start building this thing and demonstrate what it's capable of. The reality is there's billions of metrics out there, and we want to build a tool that can visualize all of them. The user, based on their needs and context at a specific time that they're viewing the map, can toggle among a vast array of settings that will visualize the map in different ways. And I'll show you, the point of this is to show you what that might look like as we build it out. The fourth disclaimer here is that this is an invitation to join us in building Moss. We want help making this data definitive, finding out what tools are used in what domain, for example, what projects are dependencies to other projects, what projects might be alternatives to other projects, things like that. This is really an invitation to join us in these discussions. We have a Moss interest group that meets once a month. We have a Moss working group that meets once a week to just build this thing together. If you want to learn more about that, you can find me at john@numpfocus.org. I'll give you all more information about that at the end of the demo here. So let's get into this. Let's start telling our stories. The first story we're going to tell is from the perspective of someone who has found a security flaw. And let's say we have found a security flaw in Matplotlib. And I guess this is a fifth disclaimer. For the sake of my computer sanity, I'm going to remove people for this story because we are using a platform called Kumu. Kumu is a brilliant platform for mapping complex systems. It has limitations, of course, and we are starting to reach the edge of what is possible with Kumu in terms of number of nodes and connections on a map. It is very computationally intensive at this point. And if you just move some of the nodes, it makes things go a little smoother. So for this story, where we find a flaw in Matplotlib, we've removed people. And now let's see how quickly we can answer the three things that are probably needed by someone who has found a flaw in Matplotlib. First, who's the fiscal sponsor of MPL, and how can I get in contact with them? Second, what other projects and packages might be affected by this security flaw I found in Matplotlib? And third, are there any alternatives to MPL that I might use to build on to fit my needs, to replace MPL if in the worst case scenario, Matplotlib needs to disappear because its flaw is so bad. Let's see how quickly we can find those. So first, we're looking for Matplotlib. There we go. We found it, and pause the timer. Here is a bunch of information that pops up about Matplotlib. Of course, all of this is just kind of information overload. So this is why we need a visual. This is why it can't necessarily be a database. Visuals are much more intuitive and very much increase the speed by which we can find information. So we found Matplotlib. Start the timer. Let's focus on it. There we go. Let us map the projects in this ecosystem to their fiscal sponsor. Great. Let's expand the focus out one from Matplotlib. And here is the fiscal sponsor for Matplotlib. It is NumFocus. Here's all the information. I will contact them, let them know I found the security flaw, and we can see if they have any other thoughts on this new flaw that we found. All right, number one is done. Now, number two, what are the other projects or packages that might be affected by this flaw? Well, let's untoggle fiscal sponsor connection, and let's now toggle the connections to dependencies. Recenter the map, and here we go. So we've got Matplotlib, which is dependent on libpng, and then you have all these projects that are dependent on Matplotlib. So we can assume here that if there's a security flaw in Matplotlib, all of these projects are at risk of being affected by that security flaw. Number two is done. All right, so number two is complete. We now know the dependencies. So I'm going to reach out to all these projects and see if they know anything about the security flaw. And you know what? That actually sounds like a lot of work for me. So let's see if I can just find the organizations that are connected to these projects so I can reach out to the organizations, because maybe one organization is related to more than one project here. So I've turned on fiscal sponsors. And you can imagine in the future, there will be other organizations, universities, funders, etc. And let's expand the focus to see that ecosystem. Oop. All right. Now let's find our Matplotlib again. You don't need this information. Here it is. If we hover over it, there's the dependency graph of Matplotlib and the associated organizations to those projects. So there, you can see that this project over here is dependent on Matplotlib. Not fiscally sponsored by anyone, not tied to any organization. All right, got that information pretty quick. Let's go over here. Our viz is dependent on Matplotlib and is connected to NumFocus as a fiscal sponsor. So by reaching out to NumFocus, I can talk to them about Matplotlib and RViz, and they'll have sort of grander context of the situation as that anchor in the open source research software space. I can do that with every single dependency. Let's go over here. AstroPi, also a fiscal sponsor of fiscally sponsored by NumFocus, so same thing. All this information, very easy to glean just by looking at a visual. Of course, as we develop this, that process of hovering, identifying, and so forth will hopefully be made simpler. We are again constrained by the limits of what is possible with Kumo. All right, and just for fun, we're going to zoom out. Your timer stopped at this point. Let's zoom out and see the entire dependency graph around NumFocus. And again, this is incomplete. You can see all these projects down here. We haven't mapped any of packages or dependencies or anything associated with these. We've done probably 25, 30 at this point. But back to our timer, let's zoom in to Matplotlib. Here's where we were with the dependency graph and the fiscal sponsor. Now, number 3, are there any alternatives to Matplotlib that I might use to build out to fit my needs should Matplotlib disappear or be out of commission for some time? So start your timer. Let's remove the dependencies. Let's remove the fiscal sponsors. Let's toggle alternatives. And again, incomplete, maybe not entirely accurate, but here's what we've got. And I'll toggle names down here, just make it a little easier to see what's going on. Here we go. So maybe we can use ProPlot, maybe you can use Data Shader, maybe we can use Altair, Plotly, or Bokeh. And done. Stop your timer. We now know alternatives we might look at to use Matplotlib. And we can do the same thing with the fiscal sponsors. Let's tie those in. And let's increase the focus. And there we go. We can trace that and see which projects are connected to which organizations, and then contact those organizations. And let's, just for fun, expand this focus and see the alternatives map for the NumFocus ecosystem. A lot of fun here. All right, so zooming back into our problem, we've already answered the 3 questions. Let's now go a step further and think, well, what's going to help us decide which of these possible alternatives is going to be best for me? Well, in deciding that, I might think, hey, my organization also uses projects that sort of run complementary to Matplotlib. And if any of those projects that we already use and are familiar with also run complementary to any of these alternatives, that decreases the friction in us transitioning to one of these alternatives. So if I could map those complementary projects and see which ones I use and are also complementary to, say, like Plotly, then that will help inform me. And if all my projects that I already use also work well with Plotly, then I'll probably use Plotly as my alternative. Let's do that. Let's map complementaries and what we call enhancements. And this is getting to the edge of what we've mapped so far. You'll see there's not much connection here. There's not many interesting connections here from like Plotly to other complementary projects, simply because we haven't mapped that far in yet. But you can see all these other red projects which we have mapped are run complementary to Matplotlib. So if any of these also, let's say Spider, run complementary with Plotly, there would be a connection right here to Plotly from Spider. And there's also that connection to Matplotlib, and we're like, hey, we use that too. So because there's only that connection to Plotly, Spider doesn't work with all the other possible alternatives, then we're going to end up using Plotly. you can see how this sort of mapping starts to expand use cases and make things easier to find in this giant ecosystem. All right, so we have answered the three questions, and we have also added a layer of information that's going to help us make a decision with that third question of which alternative should I use. Now, just for fun, let's put these back on dependency, and let's add downstream, which is another sort of experiment where we're playing with on the current version of the map. And let's expand out to see the full non-focus ecosystem in this regard. And there it is. So this is the map of num-focus dependencies, alternatives, complementary enhancements, and downstream projects. Now, something else I want to add to this is the mapping of packages to these projects. Because some of these projects, and we'll use AstroPy for an example here, are collections of many tools and packages, and not just a single package on their own. So here's AstroPy. And you can see the little micro ecosystem around AstroPy. And I just think that is very cool. And that will come back a little later when we're talking about people. But if I hover over AstroPy, I can see that entire map. And you can look at other projects like NumPy, Big Circle, lots of things depend on it. You can see the NumPy map, but it doesn't necessarily have those affiliated projects in its ecosystem. But we are done with this story. I hope you enjoyed it. Let's move on to the next story. Let's turn everything off and keep packages connected to projects. Let's remove the focus. Let's add, as we get started here, the fiscal sponsors. Again, we've only mapped num-focus, but this is, an example of what a organization's ecosystem might look like when we get it mapped. And again, you can see all the little red dots here. We have not mapped everything in this ecosystem, but you can see the projects we have, and they're affiliated projects. And then, you can add on the dependencies as we had before and everything down that tree to get an even more detailed map of the ecosystem. And at some point soon, I hope, with your help, we can get other organizations, and we can get their little ecosystem over here, and we can get another ecosystem over here. We can start to see what the threads are that connect these organizations, that connect these organizations. Maybe it's a project that is supported by both a university and has a fiscal sponsor. And that's how that university is connected to that fiscal sponsor. Maybe it's a person, and I have a feeling it is going to be a person that connects many of these organizations together. And I'll show you, you'll see why I think that will be the case as we get further into the demo. And so let's do that right now. Let's start our next story. Our next story is of a researcher who's entering a new domain for the first time. And they're presented with this. So they're lost. So let's give them a map. And the field they're entering, let's say, is machine learning. So first, we're going to toggle on the subfields. And here's another disclaimer. I'm toggling subfields. Obviously, there's many different ways to name domains, subdomains, subfields. This is just what we have on the map right now. Join us, have the conversation, and let's build these things out together. So now we have the subfields of science mapped to the different projects that are used in those subfields of science. So we've got data science over here, and there's obviously a lot of projects in num-focus whose focus is on data science in particular. A lot of projects are used in data science in the num-focus ecosystem. We've also got machine learning, computing, kernel analysis, visualization, molecular dynamics, right? So again, this person is brand new. Start your timer. We've already got a couple seconds in because we had to map the subfields. And now let's search machine learning. There we go. We found it. Let's focus on it. We only care about machine learning. And stop your timer. We now have 5 projects that are used for machine learning. And again, these red circles are sized by dependencies. In this use case, the user of the map would probably like to see these things sized based on the number of people and organizations that use these tools for specifically machine learning. And if that was the case, PyTorch would probably be very, very big. but this is not built into the map right now. It will be built in that map. It can be very easily built in, but early prototype. So I'm new to this field, and I see this big circle down here, and I click it, scikit-learn, and I see some information about it. That's awesome. Scikit-learn is a Python module for machine learning, built on top of SciPy. That's great. I now know I've heard of SciPy. Maybe I'm going to look at that later in my exploration of the map. But I want to dive deeper into scikit-learn, so I will focus on it. And this process of having to zoom out and then zoom back in is just a limitation of Kumu. I'm going to have to do that several times during this demo. Okay, so I'm now focusing on scikit-learn, and I can see it's also used in data science, machine learning, and I want to learn more about the projects associated with scikit-learn. So I'm going to map the packages, which we have not mapped yet, but I will now turn on the complementary projects and the enhancements. And I will see what other tools people who use scikit-learn are using. And here are some other projects I should learn about as I enter this space if I'm going to start using scikit-learn. Maybe I also want to map the alternatives. That's probably going to give me some more projects to learn about. Awesome. So from that big amorphous blob, I now have a handful of projects I can start to get involved with. So let's turn off the alternatives really quick, and let's focus a little bit more. Let's focus on Dask. Let's continue our journey down this rabbit hole. We're like, oh, Dask is pretty big as a circle here. Circles indicate importance for my use case, so I want to explore Dask. So refocus onto Dask. And there we go. We can see all the projects associated with Dask. This will bring me down another rabbit hole. And you can see we've mapped the packages around Dask here. And we might, let's remove these enhancements and complementaries just so we can see the packages a little more clearly. We might end up learning about Dask ML. There it is, Dask ML, which is a machine learning package associated Dask that is used with scikit-learn. So great use of the map here. We can also see that computing is something that Dask is used for. Like, all right, I want to use computing while I'm doing my machine learning work. So let's now focus on this little world of open source science. Refocus on computing, and here are some more projects I might want to explore. Right? And now, okay, I've explored these projects. I've learned about them. I've read their informative panels over here, which we can populate with a whole bunch of details, which we will populate with a whole bunch of details, more than just the description and the data that means very little when you're just looking at it. But I want to find who to contact to learn more about this. So first, I could go down the route that we have done so far, map the fiscal sponsors of these projects. Sometimes this will happen, so let's refocus on Dask here. Limitations of Kumu. And expand back out. There we go. So I now know that NumFocus is the fiscal sponsor of Dask. If I want to learn more, I can go to NumFocus. Very cool. But NumFocus is an organization. It's not a person. I particularly am interested in learning about people. So we're going to go back to the computing cluster, and we are going to really focus on it just to make sure I don't break the computer. Because as we add people to this map, you're going to see me have to reset it several times because it does stretch the limitations of Kumu, because there are so many people, right? So we're going to go back to computing, and we're going to start building our map again. So here are the 4 projects associated with computing on the map right now. And if we expand our focus, you can see the packages associated with them. And then if we expand one, oh, here's the issue. We have not matched the people yet. So let's map the people to the projects. And There we go. We now see the ecosystem, the micro ecosystem around the computing subdomain of science. See, we have three projects. Well, we have three projects mapped here. Here are the people that contribute to those projects. And then you can see what's starting to connect the various projects, and it is people. There are, I think, some packages in this one that no, there don't seem to be. There are in some micro ecosystems packages that will connect different projects or different domains. But we can now click on a person here. Let's choose, get the nodes off each other. What about Matt McCormick? So Matt is a contributor to ITK and Dask. So if I want to learn about those projects and probably the larger computing ecosystem, I can talk to this person. I can see all the packages they've committed to. I can see all the projects they're associated with. They're also with Scikit Image, which might interest me. And I can see to what extent they contribute to these various packages and projects. And again, please don't read too much into the metric we are currently using. It's just the number of commits that we got off GitHub. But this visual is very interesting. And the reason I'm showing you this small visual is because it's going to get very noisy in a moment. But before we make it too noisy, let's summarize what we just did, the story we just told. We are a researcher new to machine learning. We founded the projects that contribute to machine learning. We found one we want to dive in on. We found the projects that are used in association with that project. Scikit-learn is used in association with Dask. And then we learned that Dask is also associated with computing. And we thought, hey, we're going to use that as well in our research with machine learning. And so we mapped the computing ecosystem, and we have found some people that might guide us on our journey into this new domain of ours. So now I'll say a little prayer for my computer, and let's map everything. And let's see what starts to emerge. All right, it looks like we're at a point where we can expand our focus. So that took about 4 minutes for just the map to interpret all the data to start mapping the ecosystem. And here we are with the computing subfield and the map of dependencies, alternatives, people, projects, fiscal sponsors. And now we're going to clear the focus and look at the entire map of what we've mapped so far. Oh, here we go. You can see the struggle is real, but you are starting to see shapes take place. Whatever this project is in the middle is probably core to the projects we've mapped so far. NumPy. I don't think many people would disagree. These other projects also seemingly core to what's going on in here. This pink organization, seemingly core to what's going on in here. And I'll just point out, it is the only organization mapped, so that's probably why it looks like the core organization of what we've mapped. This domain seems like most projects are working on this domain. It's data science. And these other domains out here, they seem ripe for innovation, for contributions from open source developers, from funders to support projects in that field. These people, these giant orgs, seem to be core to this system. There's particularly the ones that are in between projects. This cluster down here, all the people here in this middle seem to be core to this ecosystem. The people out here seem to be very passionate about singular projects, particular projects. I think this might be ITK, GDAL. Okay, GDAL. All these people love GDAL based on what we've mapped so far, and again, based on very bad metrics and measures, based on just the number of commits people have made to projects. An example of this bad metric. And for the sake of my computer, I'm going to remove a lot of people from this map really quick. I'm going to remove everyone who's committed fewer than 10 commits to any of these projects. And I know in doing this, I'm removing a lot of originators of these projects. But there you go. You can see it really helps with the visualization. So here we go. We can see this person. No, not that person. This person has committed 28,318 times to these projects, and they've got the biggest circle. 28,000 of those commits were to GDAL. One of them was to AstroPi. So, right, improper way to, or a very inaccurate way to visualize this person's contributions. It is more likely that this circle should be right next to GDAL, but instead it's sort of in the middle. It's between AstroPi and GDAL. At the same time, maybe this one commit is the entire code base of AstroPi. So there's a lot that can just be gleaned, a lot of insights that can be gleaned from just looking at this visualization, this incomplete, inaccurate experiment of a visualization of the open source software ecosystem. And we haven't even begun yet. We have papers to start mapping. We have to tie those papers to the people who contribute to various open source projects. We have so many more organizations to start mapping and to start playing out some more stories. We want to tell the stories of funders so that we can let people explore what the impact of their funding truly is and where they should put their money in the future. Throughout all of this, we want to keep a focus on the people that run it all. The people are the things that build these projects. People are the things that organizations support. When you fund a project, when you fund maintenance of a project or innovation in a new one, you're funding a person. And as we start to see in this map, people take up all the space. Hyperbole, obviously, but there are also many of the connecting threads. And as we build out these other organizations, this is why I think we're going to start to see people being the connecting threads among organizations. So again, this is a demo of an incomplete, oftentimes inaccurate map, really trying to show what we're trying to build with the map of open source science. And it is also an invitation to join us in building the map of open source science. So I'm going to remove all the connections here. So in removing all those connections, it crashed my browser. So I've reloaded it, but I've removed all the connections to show you once more the problem that we're dealing with. So let's add people to the map. We're trying to map this ecosystem so that people can navigate it when they need to navigate it. So I invite you for the last time to get involved. Feel free to email me at john@numfocus.org and let me know what you want to do, and I will connect you where you need to be connected. You can also join the MOS interest group or any of OSI's interest groups to talk further about how you want to contribute to mapping the open source science ecosystem. For that, thank you for joining me for these stories, and I hope you have a wonderful day.